Hey guys, it's Miss Meckling again. This is our third set of notes. So this is on graphing, which is the step of the scientific method where we analyze data. Again, we're not doing a dictionary. We don't have a binder because we're all virtual right now, so don't worry about that at the top. All right, so it says graphing is an important procedure used by scientists to display the data that is collected during a controlled experiment. So we got to talk about what is a controlled experiment. That is when only one variable changes and the rest is exactly the same. You use a controlled experiment versus the experimental group. Remember, a control group is one that gets what you're testing. The experimental group gets what you're testing. The control is what you're using to compare it to. Okay, so in an experiment, you only have one variable that changes so that you know the results. And again, a controlled experiment has a control group and an experimental group. The control group would not get what you're testing, the experimental would. So if you're testing like a new pharmaceutical drug on something, you would, for example, have different groups. One that doesn't get the medicine at all that you would use as comparison, and then maybe 5 or 6 groups that get varying amounts of the drug that you're testing. So again, it has to be a controlled experiment. So there are 3 different types of graphs. The pie graph, or sometimes called the circle graph, is used to show parts of a whole. So this is percentages here. A bar graph is used to compare amounts. And a line graph is used to show the change of one piece of information as it relates to another. Now, we typically use a line graph when you're controlling one of the variables. So let's talk about what a variable is first. A variable is a part of an experiment that changes. When you're controlling one part of it and the other one is a result, that's when you would use a line graph. A bar graph is when both data changes. So you're not setting limits. So if you're just randomly sampling different days of the week at Fort Hays and looking at the number of boys versus girls on those random days, that would be a bar graph. Okay, so a line graph is where you control one of the variables. So those are the 3 different types of graphs. Let's talk a little bit about line graphs. Get the X. So typically when you have a piece of, let me use my pen, a graph, you have a horizontal axis, which is going to be your x-axis, so that would be down here. And then your vertical axis, which would be your y-axis, that goes up. Okay, and then this one goes across. So on your x-axis and your y-axis, you have to use the right label. Okay, so parts of a graph, we call it the task method, T, A, S, actually there's a P there, but it's silent, and K. So we're going to go through these 5 steps of graphing so that you get your graph done correctly. All right, so you're going to have some graphs to do, and these are the things that I am expecting you to do on them. So very first thing is the title. You have to summarize the information being represented in any graph. Dependent variable always listed first versus the independent variable. So let's talk about that. The dependent variable is the variable that is the result. It depends on the other one. The independent variable is the variable that you control. Okay, so it's the part that you go, okay, I'm going to take this data every 5 minutes. So clearly we can't control time, but you've controlled the time increment that you're taking the data. So the one that's controlled, it goes down here. And the one that is your results will go on the y-axis, and so your title will follow this format. Okay, it's always your your dependent variable right here, so that will be whatever's on your y will be listed first, your dependent variable, and then that will be versus your controlled, which is your independent variable. Okay, so that we'll call it controlled. So it's going to be your dependent, your results versus your controlled, and that's your independent variable. Okay, so independent variable, a variable is anything that changes. Your independent variable is always second. Your dependent variable is always first. Okay, so your title should always summarize the information being represented in any graph, dependent variable versus your independent variable. And that goes at the top of the graph paper. Then you got to label your axes. A stands for axes. So we've got T stands for title. A stands for axes. So your axes, which I already said down here, your controlled variable goes on the x-axis, your results or your dependent variable go on the y-axis. Make sure you have your units. Units need to be listed. So is this time in minutes, time in hours, volume in milliliters? What is it? Okay, so label your axes. So here's the definition again of independent variable. It is the variable that is controlled by the experiment, such as time, dates, depths, and temperatures. This is placed on the x-axis. Your dependent variable is your result, and the variable that is directly affected by the IV, which is independent variable. It is the result of what happens as time, dates, depths, and temperature are changed, which we defined as the independent. This is always placed on the y-axis. So again, up and down. All right, the next one is probably the hardest one. And I'm going to read this to you, and then I'm going to give you a little formula to help you realize what the S is. The S is for scale. So what are the increments that I'm going to go by along the X and Y axis? When you have a graph paper and a grid, you have to use the whole grid. Okay, you don't want like the full graph paper and your graph is only here. Okay, you want to use the whole thing. So you have to figure out what's the scale that you're going to count by on the X and Y axis. And so let me read this to you real quick. Okay, it says, in constructing a graph, one needs to know where to plot the points representing the data. In order to do so, the scale must be employed to include all the data points. Thus, must take a conservative amount of space. It is not suggested you have to have a run-on scale, making the graph too hard to manage. The scale must start at 0 and climb in intervals such as multiples of 2, 5, 10, etc. The scaled numbers must be determined by your data value. So here is how you determine data. You are going to take your highest data point and you are going to divide it by the number of squares or grid on the axis. So if I have 50 little squares going here, and my highest data point is 100, that would be 100 divided by 50. And then you would go by twos, okay? Or I'm sorry, yeah, you go by twos. So it'd be 2, 4, 6, 8, and so on. Do not skip spaces. Do not skip spaces, okay? Sometimes your increment might be 0.67. And the little trick on your calculator is if you hit 0.67 plus 0.67 and just keep hitting the equal sign, it'll keep adding that same thing over and over again. So calculators are really nice for this. All right, the P, which is silent in our task method, stands for plotting your points. You have to know that in science, we're really going to be using a line graph. We don't use scatter plot or anything else to learn in math. So you've got to actually plot those points where they intersect at the right spot and then connect them. And they always connect to 0. And we're going to talk about things outside of your data points. But you got to plot your points and you got to connect them. That's key. And speaking of key, the next the next point, the K, the task, the K in task is for a key. You don't always have to give me a key. You only have to give me a key where it says right here, a code that is used when using one or more sets of data points are plotted on the same graph. So when you're plotting more than one set of data points, you might use a color code or a symbol to represent, or even maybe even the line type. And then off to the side, you've got to say key and say, you know, stars are for this day 1 and maybe triangles are for day 2 and so on. So give me a key only when you're plotting more than one sets of data points on the same graph. Okay. Now, speaking of that, the last thing we have to talk about is median and mode are numbers that you've talked about in math. We don't tend to use that too often in biology. That would be more of like a physics thing. But when the data is, for example, not within the data, like you didn't actually collect that data point, but maybe say it's in between here and here, we can figure out numbers in between. based where it is on the line. And then if it's before or after, we can figure out, maybe estimate trends. You see that a lot in the data that the governor gives for COVID. So extrapolate means extending the graph along the same slope above or below the measured data. So that'd be outside the data points. So if I collected data starting at 10 minutes, I could extrapolate what happened at 2, and maybe I stopped my data collection at 30 minutes. I could extrapolate what happened at 45 minutes, okay, based on the slope of the line. Then intrapolate is points in between measured points. So if I took measurements every 5 minutes and I got data at 5 minutes and 10 minutes, I could figure out what it would be at 7 minutes. So like in between the data points. That's intrapolate. So let's review our vocabulary for this. Again, these are, I just printed it off a Quizlet. So variable is any part of an experiment that changes. Independent variable is a part of an experiment that we control, okay? Dependent variable is part of the experiment that is the result. It depends on the independent variable. So if you ask yourself which depends on which, it will tell you which one goes first in the title, which one goes on the y-axis, and this is what it depended on. It doesn't depend on anything. That goes on the x-axis, second in your title. So a line graph is used when one of the variable measured is controlled. A bar graph is used when neither of the variables is controlled. It's very random. A pie graph is a graph that shows parts of a whole or percentages. And then intrapolate is using a graph to figure out data that would occur between. A keyword there is between actual measured points. And extrapolate is the same thing. It's just outside the data points. So use a graph to figure out data that would have occurred outside, before or after the actual measured plotted points. All right, again, if you have any questions, let me know. And again, these are all on Quizlet. Make sure you get your Quizlets completed. And you only have to do one Quizlet and the test to 100%.